Good morning, everyone. Today I am going to present the topic Ford-Fulkerson method, which comes under Unit 4, Iterative Improvement and String Matching in the subject Analysis of Algorithm. This algorithm is very important in solving maximum flow problems in networks. It helps us determine the maximum possible flow from a source node to a destination node. The method is widely used in transportation system, computer networks, water supply system, and many optimization problems. In this presentation, we will understand the concept, working process applications, advantages, and limitation of the Ford-Fulkerson method in a simple and meaningful way. Ice-breaking section. Before learning the algorithm, let us imagine a real-life situation. Suppose water is flowing through several connected pipes from a water tank to houses. Each pipe can carry only a limited amount of water. Our goal is to find the maximum amount of water that can reach the houses without exceeding pipe capacity. This is exactly the idea behind the Ford-Fulkerson method. The algorithm checks different possible paths and send flow through them step by step until no more flow can be added. So this real world example makes it easy to understand how flow network works. Empathize. In the slide, we understand the need for solving network flow problems. Many industries face situations where resource much more efficiently from one point to another. For example, data transfer in computer networks, traffic movement in road, water distribution system, airline scheduling system and define. In this Ford-Fulkerson method, two important concepts are maximum flow and bottleneck. Maximum flow means the greatest possible amount of flow that can move from the source to the sink node. A bottleneck is a edge with the smallest capacity in a selected path. This bottleneck limits how much additional flow can be sent through the path. For example, if your path has capacities 10, 8 and 4, then the bottleneck is 4. So only 4 units of flow can pass through that path. Algorithm repeatedly find augmenting path and update the flow using the bottleneck value. Ideate. In this stage, we think about possible ways to improve network flow. The main idea is find a path from source to sink, check the remaining capacity, send flow through the path, repeat until no path is available. This process gradually increases the total flow. The Ford-Fulkerson method uses iterative improvement, meaning the solution improve step by step until the optimal maximum flow is achieved. Algorithm overview. The Ford-Fulkerson algorithm work using augmenting path. An augmenting path is a path where additional flow can still be sent. The algorithm follow these steps. Start with zero flow. Search for an augmenting path from source to sink. Find the bottleneck capacity, add flow equal to the bottleneck value, update the residual graph, repeat the process until no augmenting path exists. Flow network. A flow network is represented using a directed graph. Vertices represent node, edges represent path, capacities represent maximum allowed flow. There are two special nodes, source node when flow starts, sink node where flow ends. The flow through any edge cannot exceed its capacity. Flow networks are useful in modeling real-world systems such as internet data transfer, road traffic system, pipeline system, supply chain management. And residual graph. A residual graph should the remaining capacity after sending some flow through the network. It is very important because it helps the algorithm determine whether more flow can still be added. For example, if an edge has capacity 10 and already carry flow 6, then the remaining capacity is 4. The residual graph update dynamically alter every iteration. It also allow reverse flow, meaning the algorithm can adjust previous decision if a better path is found later. This makes the Ford-Fulkerson method flexible and efficient. For example, let us see a simple example. We have source to A capacity 10, A to sink equal to capacity 5. So source to sink capacity is 7. First, the algorithm select the path source A, sink. The bottleneck is 5 because A, sink has a smallest capacity. So 5 units of flow are sent. Next, The direct path source sink is used with capacity 7. So another 7 units are added. Finally, maximum flow equal to 5 plus 7 equal to 12. The algorithm this example clearly shows how the algorithm calculate maximum flow step by step. Next is working process. So some steps are there. The algorithm stops only when no additional flow can be pushed from source to sink. And applications. The Ford Fulkerson method has many real-time applications are there, and advantages and limitation is simple and easy to understand, efficient for many practical problems, and assessment. Let us quickly revise with the multiple choice question. These questions help us understand the core concept of the algorithm, and the Ford-Fulkerson method is used to find maximum flow in networks. It works by repeatedly finding augmenting path. Thank you everyone.